Okay, last video. We're now going to be talking about surface areas. So we're switching gears here, okay? Not talking about filling a three-dimensional figure or a 3D solid, but this time we're covering the outside, okay? So surface area is covering the outside, not necessarily filling the inside, okay? So if you were to be talking about painting the outside of a box or gift wrapping an outside of a box, okay? Painting, that would be covering its surface area, okay? Or wrapping a gift, you're also covering the surface area of that object, okay? So I always like to think of gift wrapping. It makes sense to me. I'm covering the outside of a figure, so I'd have to find the surface area to know how much I need to cover, okay? Now this is in volume, so there is a bit of a shift. You're just in square units. It's not going to be cubic units. Okay, you're only multiplying 2 dimensions, not 3 dimensions. Okay, and surface area is really just covering the outside. So you're really just covering a bunch of 2-dimensional figures. So in a rectangular prism, you're covering 6 rectangles. Okay. In a triangular prism, you're covering 2 triangles and 3 rectangles. And so there are several formulas that you can follow. So if you were to Google, you can find surface area formulas for all of your 3-dimensional figures, any pyramid, any prism. But they're all going to have different ones because they're all made up of different shapes. And there's no kind of general rule to follow like there is for volume, unfortunately. So they would be all different, making it nearly impossible. And it's not really the best way that you should go about finding surface area. The best way to go about finding surface area is to actually add together the areas of all of the sides. Okay, so let's go ahead and take a look at how that works. Okay, so with your surface area of a rectangular prism, okay, there are 2 rectangles that measure 2 by 5. Okay, there are also 2 rectangles that measure 2 by 3. And finally, there are 2 rectangles that measure 3 by 5. If I can find the areas of all these separate rectangles and add them all together, that is all that needs to be done to find the surface area. Okay? It's like I'm taking apart this 3-dimensional figure into what 2-dimensional figures make it up. Then I take the area of all of those 2-dimensional figures and I just add them all together. So the ones that are 2 by 5, these are all rectangles, so it's all base times height or length times width or length times height, however you want to look at it. Okay, so I have 2 times 10, 2 times 6, 2 times 15. By all means, you could do this in much fewer steps than I'm doing right now. Just because this is our first demo, I'm going to go a little bit slower for you. So right here, we're looking at a surface area of 62. I didn't have any original units there, so let's just say units squared. Okay, so if I needed to know how much paint I need to buy, I need to make sure that I can cover 62 square units, whether that be feet, yards, whatever. Okay, let's take a look at a triangular prism. Okay, so in this triangular prism, here, this would be a little bit, take a little bit longer than this one here. So let's take a look at both of them. Neither of them take that much time. So the surface area of this triangular prism, you have 2 right triangles that are the same. They have a height of 3 and a base of 4. Okay. You have 1 rectangle down at this kind of bottom right here that measures a 4 by 15. Okay. I then have this back, I guess we could call it, this back rectangle here that measures a 3 by 15. Okay, and finally I have this kind of front one here, or slanted one if you will, right here, that measures 15 by whatever length that is, okay? And that I'd have to find. The thing is though, it's not all that bad because it is this right triangle here where you have 2 out of the 3 known sides. And because it's a right triangle, I would be able to use Pythagorean theorem. Also, it's a very common triplet. It's a 3, 4, 5. So you don't technically even have to use Pythagorean theorem if you can remember it's a triplet, and it's a very common one. So then that final triangle is going to be a 15 by 5. I said triangle, I meant rectangle. Okay. So the 2 triangles are going to be a half base times height. Okay. Then you have a length times width and a length times height and a base times height, whatever you want to call it. I'll say length times width because that's probably the most common that we use for rectangles. Okay, now I'm just going to go ahead and plug in my numbers, right? So the base and the height for your triangle are 3 and 4. Okay, this was a 15 by 4. This is a 15 times 3, and this is a 15 by 5. Okay. You can realize here that the 2 and the half are going to cancel out, but I'll do it kind of in a long way also. So 3 times 4 is 12. Take half of that, so that's going to be 6. So one of your triangles has an area of 6. 15 times 4 is 60. That's 45, and that's 75. Okay, that's going to end up being 12, and now it's just a quick addition that needs to be done, and you're looking at a surface area of 192 square inches for this one. Okay. I'm not going to do this one. Well, I guess this one is actually a lot faster, so I'll go through this whole one. Okay. So this one is just a bit quicker because all of your rectangles are the same because you're dealing with an equilateral triangular base. Okay. I know all 3 sides are congruent. Okay. That means that all of your rectangles are a 10 by 31. So instead of having all of these separate parts here, you're really just going to have 2 triangles, okay, that all have the same base and height. It's a height of 8.7 and it's a base of 10. Okay, and to that you're going to add the 3 rectangles that all measure 10 by 31. So it's a little bit quicker on this one. So you have your 2 triangles and your 3 rectangles that are all the same. So half your base was 10, your height 8.7, and your 3 rectangles are 10 by 31s. Okay, so you're looking at your triangles having an area of 43.5, and all of your rectangles having an area of 310 square feet. So you're looking at covering 87 square feet of your, and again, that would make sense because remember what I said on that example, that these 2 kind of cancel each other out. So essentially there was that 10 times 8.7 to give you 87. And then your 3 rectangles will cover 930 square feet. And so your total surface area, 1,017 square feet. Okay. Almost to the end. I do want to talk to you quickly about well, actually, we'll talk quickly about this one. This one should go pretty fast as well. So your surface area here, you have 2 of those hexagons that are regular hexagons, okay? And we actually, in the first video, we already found what the area of that was. That was an apothem height of 3.46, okay? So your hexagon will be half the apothem times the perimeter. Your perimeter was 24 because there's 6 sides at 4 millimeters each, so it's just 3.46. So I have 2 half apothem times perimeter that I'm going to need to do. Plus, you have 6 of the same rectangles. So all of your rectangles measure 4 by 7. So this one's actually pretty quick if you think about it, okay? So your, in one of the previous, I think it was the first video, yeah, it must have been, because this is a prism, we found that this area was 41.52. Okay, so you have 2 hexagons at 41.52, the top and the bottom, plus the 6 rectangles that have an area of 28. So this is obviously going to be 83.04, and then 6 times 28, that has an area of 168, and so your total surface area for this prism would be 251.04 millimeters squared. Okay, the last thing I want to talk to you about is your cylinder. Not because it's difficult, but just because of one concept about that rectangle. So let's just realize that you're dealing with 2 circles, okay, that have a radius of 8. Okay, and then you have 1 rectangle that wraps around your circle, okay? So we'll talk about your 2 circles. They're both going to have an area of pi r squared, okay? And your rectangle, which is base times height or length times width, we've been using length times width, right? So the circles are easy, right? You have a radius of 8, okay? And then your rectangles. So your rectangles have a height of 12 and a base that we don't know. So let's talk about your rectangle, right? So here's the one side of your rectangle. The other side of your rectangle is what's wrapping around that circle. So it's really covering the distance around the circle. The distance around the circle is what we know is called the circumference. So the length or the width or whatever dimension you want to look at it as being one of your sides of your rectangle is actually going to be the circumference of the circle. Okay, the circumference of your circle, you should remember this, but if you don't, it's 2 pi r or pi d, depending on what you have, but 2r is d. So I have a radius of 8 here, so my circumference is going to be 16 pi. That means that the one dimension here is 16 pi centimeters, okay? So you don't have your length of your rectangle in terms of just a number, it's in terms of the circumference of the circle, because that's what's wrapping around it. So the circumference, so the length will be 16 pi, and your height or your width, whatever dimension you want to call it, would be 12, okay? So I have 2 circles that have an area of 64 pi each, and then my rectangles, or my rectangle, has an area of 192 pi centimeters squared. So I have 128 pi for my circles and 192 pi for my rectangle, okay? And
because these both include pi in them, they can be added together. They're like terms. It's like saying 128x plus 192x is equal to 256x. This is equal to 256 pi. And then, of course, centimeters squared.
Okay. And we may as well take a look at one more. Let's look at this pyramid, okay? So your pyramid here is nice because it is a square base, so you would avoid having to have more than one different triangle here. If it was a rectangular base, you'd have two of the same triangles and the other two triangles would be the same. So you wouldn't have four of the same triangles, you'd have two of the same. So the surface area here is a little bit faster because you have a square base and four of the same triangles, okay? Your triangles have a base of 20 and they're giving you a lateral height or a slant height, so we talked about that in the second video. That height of 26 is representing the height of the triangular base. You can see that it's kind of slanted and they mark it perpendicular down here as opposed to perpendicular in the center of the base. So because they're marking it perpendicular on this triangular base, we understand that the height is always perpendicular to a base, so that's going to be the height of your triangles, okay? So your square is going to be 20 squared plus you have four triangles. One triangle is half base height, so you're going to have half 20 times 26, okay? This is another thing that you could take kind of a shortcut here. 4 times a half is going to break down to just 2. I'll do it in kind of 2 steps though, but you could just kind of eliminate that right away if you wanted to. So let's see. So I have 4 times each of my triangles is going to have an area of 260. So my 4 triangles will have an area of 1,040, giving me a total surface area of 1,440 square centimeters. And that's it, okay? So what I was saying before is if for some reason this was, let's say, that I didn't know this and that this was 35 centimeters, okay? You now have a rectangular pyramid, so you would have this triangle here and here would be the same, but kind of the front and back triangles would be different, okay? You also wouldn't have a lateral height on that, but you don't necessarily have to worry about that. I don't think it comes up on your worksheets, okay? And that's it for the video, so now make sure that you complete your worksheets, and I will see you next class.